Hello everyone, this is Gaurav from Automation Hacks and welcome to a new video on Java for test automation. In this video, we are going to take a look at three new features that were introduced in Java 21, starting with pattern matching for switch, record patterns, and lastly, virtual threads. All of these are very interesting, so let's get started. Our first feature is pattern matching for switch. And if you have been following previous videos, you will see that this is a pattern in Java, wherein now Java is allowing more and more ways of recognizing certain patterns in classes and making code more concise. So let's take an example to understand this. So if you have been following the previous video, we talked about sealed classes, and here I have another sealed class hierarchy that resembles pretty much what we discussed last time. So just to repeat, we have a sealed class called as employee that allows two child classes, leader and engineer. It has a couple of variables and a constructor and a getter. Similarly, we have a subclass leader, which is a final class, which means there can be no child classes created for it. It extends employee, and in general, it just defaults to whatever name is provided in the parent class and just uses that only. Now I have another subclass called as engineer, which is non-sealed, which means we can actually create more subclasses of engineer, and it also extends employee. So pretty much same. Now let's look at how pattern matching for switch can actually be used in such an example. So here I have a test class, um, and here I have a test method, right? So what I'm doing first is I'm creating a list of new employees. Now, what you notice is I have engineer and leader as two subclasses of employee, and I'm using the base class as a way of storing objects of those child classes. This is usually a good programming principle wherein you're always programming to an interface rather than a very concrete class. And here, in that same example, I've created two objects of a leader and an engineer into a list. Notice that I've used var to make the code a bit concise. Now say I want a simple for loop where I want to iterate in this list, and then basis what kind of object I get, I want to do some simple actions, right? So I start a for loop. I use the same base class of employee, and then say I want to get a description of what role they are playing, right? Something like that. So I start my switch statement here and I'm passing the employee object here. Now this is where the pattern matching for switch actually comes into picture. If you notice, in the case, I have specified what type of object, employee can be, and immediately Java is able to recognize the type. It is able to match what type of employee is at runtime to a specific case, and then you can specify an implementation. So in this case, I am very much doing a very simple thing where I'm just getting the name of that object and I'm interpolating it into a string using a string interpolation and using dot formatted for that. Similarly, if the object is of type engineer, then I'm doing something similar. And lastly, if I don't have any object that matches, then I'm having a default case where I'm throwing an illegal state exception with a message, right? Eventually, I'm just checking that the role description that I get out of this, it should have, a valid name. Basically, some name property should be set. So let us just check if this code works fine. And yes, the code passes. We can see that we created these two objects of an engineer and a leader, and the test successfully passed. It checked that a valid name was returned. So this was one example of pattern matching with switch. Now let's take it a little bit step further and also see how it can analyze null values. So here I have another test where I'm trying to demonstrate the same thing, that we are able to pattern match within switch even for null types. So this is the main thing to pay attention to. I have a get confirmation message which takes a string as an input, and it has an output that it wants to return. Now, you might want to check that, okay, if this input is of type null due to some reason, then you might want to give it a default value. And so now switch can also match a null type. And here I am just writing a single line statement where I'm assigning a string to output directly, right? On the other side, you might have some specific strings basis which you might want to take a specific action. So now you can again pattern match with string s. You can give the type of whatever this variable would be. And then you can also create a block here. Now within this block, I have an if else chain. If it is yes, while ignoring the case, usually a good practice in test automation, not to hard code on, case. And you just say output as confirmed. If it is no, then you confirm, say it is at not confirmed output. Otherwise, you just say invalid input and you return the output. Now, say you have this test method where you call get confirmation with different values of yes, no, null, and invalid, and check that it indeed matches. So yes, this test passes as well. Now, moving onwards, we can take it a little bit step further, wherein we can also use null along with a when clause. Let me show what that looks like. So I have another version of this method called as get confirmation v2. And you will notice that this is similar to the previous method where I have the output and I have the same cases. It's just that I have expanded the if clause using when. So now it reads something like this. If my string, if whatever input I'm passing is of type string, then I can specify a condition using when. And I can just specify what is my condition. This is similar to what we had in if clause. If it matches yes while ignoring the case, then the output should be confirmed, not confirmed, and invalid input. So you can see now you don't have to wrap your head around a complex if else kind of nested chain. The syntax is much more simpler to read and much more easier to reason about. And that's pattern matching for switch in a nutshell. I hope you will use it in your automation, as I definitely think it will make your code more concise. Right. So now moving onwards, let's also understand how pattern matching can also be applied to records and how it allows you to sort of destructure complex objects in your tests. And you can also read more about this in this excellent blog article that I've linked at the top and from which this example is picked. So here I have certain record classes. As I already talked earlier, we can use record classes to create immutable DTO kind of objects with getters and constructors. So I'm trying to create a representation of some geographical point on the map. So I have a GPS point class with a latitude and longitude. I have then a location object which has a name for this given point, right? And lastly, I also have a generic wrapper which can take a type of any specific type T and it can associate a description to it. And we can say that, okay, this is a wrapper class, right? Sometimes you might have to write code like this. And let's see how record patterns can help us destructure this more efficiently. So I've created a location using a simple sort of construction syntax where I have the name as home and this is some GPS point. Now, if you want to say access the value of the location within this location object, within an if clause, you can of course say if this location is an instance of type location and give it a variable name like we saw pattern matching being supported earlier, then I can just access location's name directly, right? I don't need to do that syntax of again casting the object into location and then using it. So this is fair enough, something that we saw earlier as well. Now let's take it one step further and try to see how this would work if, like if you wanted to destructure even the values inside the GPS point. So here I have the same example, but this time I'm actually giving it an instance of location. Notice I'm giving the outer type that this given location has. And inside, I've actually destructured or expanded each of the members. So I've given the name as string. I've also given, the expanded form of the actual GPS point with latitude and longitude. And if I use it in this way, then within Java, I'm able to pattern match and destructure the record class directly. So now the subsequent code doesn't need to, do like dots and things like that to access even the nested inner value. It directly can specify, hey, I want to check that the name is home, latitude and longitude is this given type. And this is very much convenient. So we can run this test, and of course this passes as well. Lastly, let's take a look at how it would even work with the third wrapper object that I have. So in the same vein, you can see that this code is pretty much similar to what we just saw. We have expanded location. We have given string as description, and then we have said that, okay, this is an actual instance of wrapper within this location. Now, since that was a generic type, we can pass location or any other object which kind of matches the syntax. And I can then, yes, access the inner values and then directly just write my test. The last feature that I want to talk about from Java 21 that can make sense for automation is virtual threads. So now virtual threads is a new upcoming feature that is introduced, and it is essentially threads which are more lightweight in nature, and they are directly managed by the JVM. These are not really bound by operating system threads, and all of these threads are managed and scheduled by the JVM. This has a lot of potential in the future to unlock greater performance for parallelism and things like that. So let's take a look at a simple example of how we could create a virtual thread and run some code in parallel. So I've had a simple try block here within a try with resources syntax within Java, which means that whatever executor I create here, it's going to get closed automatically when the try block exceeds. I've created an executor using executors and new virtual thread per task executor. This is a class that I can use. And inside this, I can then specify, okay, how many virtual threads I want to spin up. So say I want to spin up 500 virtual threads, at a given time. So I have this int stream with range closed with a range that I want to operate in. I have a for each statement, and then I just have a executor.submit, which can take a lambda function, basically some logic that I want to execute in parallel. I'm not doing anything fancy. I'm just printing, what is the task, what is the number of thread, and then I'm printing the, current thread's name and ID. And within this, I'm just sleeping for a second, and if interrupted, printing the stack trace. So let's run this test and see this in action. So what you can see is, okay, it actually spun up these many different threads and I could run them concurrently and pretty efficient. It also terminated when the logic completed. So this is also a quick way of probably, writing some parallel code. It could be useful if you are writing a utility to dump some load, or you want to just see whether your given API works in a parallel setup and whatnot, right? And that's all for this video. I hope you found this helpful, and you will use these features in your code and make it much more concise and much more performant. If you find this content helpful, please give it a like and a share and a subscribe. Subscribes really motivate me to make more of these content for you. And I guess I'll see you in the next one. Bye.